This meeting is being recorded.
So yeah, last week we discussed about the dynamic resource allocation that's already in alpha in Kubernetes, and then our other KEP, QoS resources KEP, and how they might fit in some of the multi-networking use cases. And then for this week, I put in the agenda kind of follow up to tell a bit more about the QoS resource KEP, what's that about, and kind of a proof of concept demo on like general network QoS that I've set up now by few colleagues from Intel, me, Markus, then Patrick Oli, who is the kind of DRA specialist, and then Alexander Kanevsky, and then Patrick Flucht as well. And I have a few slides to present to you, so if I'm able to get some co-host rights, I could start with those and then show the demo.
Sure, sounds good.
Yeah, okay, looks cool. Yes. So, do we see anything? Do you see the slide?
Yes, go ahead.
Yeah. So yes, I'm going to present like overview on intro to the QoS resources KEP. So this proposal is about improving like quality of service of applications in Kubernetes, like a general QoS mechanism for different kind of, let's say, resources or resource sharing or throttling. I start with a slide. I took a look at the kind of multi-network requirements KEP that is already available in the enhancements repo, and try to kind of map those user stories currently present there, how they might be served with the different mechanisms that we have in place, or the proposals or mechanisms. So here we have like, I have the user stories, then I have like three different technologies or proposals. The first one is the DRA, dynamic resource allocation, which is so far like device allocation and attachment, a very flexible way of doing that we discussed in quite detail last week. Then the other column is QoS resources, this KEP that this presentation is mostly about. And the third one is NRI, node resource interface, which is a plug-in mechanism, now very new experimental thing in the CRI-O and Containerd runtimes at the moment. So kind of pluggable runtime level extension interface. So generally, I think that kind of DRA would probably fit or be able to kind of resolve, as far as I understand, or as my best understanding, kind of all the usage scenarios, if any. So it's very like flexible and flexible mechanism to like have a parameterization, multiple kind of devices or interfaces and so on. But it's also kind of heavy mechanism in sort of that you need to have the scheduling is heavier, and you need to have like usually like node per node driver to do the kind of allocation and management of the interfaces. So in that sense, I put some green boxes to the QoS resources, kept that it could in some scenarios, the QoS resource kept probably help or be an option to implement some scenarios. Basically, what I'm thinking about is scenarios where kind of selecting the default network or giving some kind of parameters to the default network. So in that kind of scenarios, the QoS resource kept could have some coverage here. That's kind of my thinking here. Then about the usage scenarios 7, 8, and 9, I wasn't really sure about the details. What kind of proposal, if any would be able to serve those usage scenarios. Let's go forward. So this QoS proposal, it's about adding a sort of new type of resource to Kubernetes, and the goal is like general to be able to improve the quality of service of applications by enabling some technologies and mechanisms that are so far like not available in Kubernetes. So we are talking, for example, cache and memory bandwidth control, or like some block.io C groups controls are good examples that we are targeting here. Then we have also been prototyping with network QoS in this space as well. There's the link to the KEP, and well, at the moment we're kind of targeting for alpha in Kubernetes 128. And the KEP is basically about adding a new fundamental resource type to Kubernetes. So kind of assigning certain identifiers like bronze, silver, or gold to containers and pods. So kind of tagging those with the identifier instead of allocating some specific amount of resources or allocating some like numerical capacity. And one general idea is that multiple containers of pod can be assigned to the same class. And one design principle here is that the QoS resources would be as opaque to Kubernetes as possible. So configuration and management of these QoS resources would be handled in the container runtime or below, but anyway below Kubernetes. So Kubernetes only knows what types of QoS resources are available and which nodes and which classes of each type of QoS resource. But Kubernetes doesn't need to know about the implementation details. So as opaque to Kubernetes as possible. And then like short or simplified picture how it would look like from the kind of architecture point of view, how the QoS resources would play out. So in the simplified picture, just that one node of a cluster depicted, an API server and scheduler from the control plane. And in this picture, everything like starts from the step 1 under runtime, they're initializing QoS resources. So kind of initializing or discovering what kind of QoS resources and classes are available in the system. The runtime is responsible for that. And then in step 2, runtime advertises those QoS resources to Kubelet, and then Kubelet in turn in step 3 updates the node status with those QoS resources. So in this case, example, we would have 3 QoS resource types like A, B, and C, and then some classes like for resource A would have gold, silver, and bronze classes and so on available on this node X. And then in step 4, the pod is created, an API server, and it would have some requests for QoS resources. The requests are really simple, like resource name, a class name type of key value pair, basically. So no no arbitrary parameterization of that class. So just the resource type and class name. And then the scheduler picks that pod up and does the normal filtering, or possibly scoring, and it sees that okay, node X is actually able to satisfy the QoS resource requests. So node X has, for resource A, it has class gold available, and for resource C, it has class high priority available. Then it schedules it onto the node X. The Kubelet takes the pod spec, and then Kubelet then over CRI gives the information to runtime about the QoS resource assignments. And then in the last step, number 8, the runtime and then actually enforces or does the tricks to actually apply whatever the resource QoS resource assignments mean. But anyway, it enforces the resource assignment. So any questions, comments so far?
Yeah, Marcus, I had a question.
Yeah.
Isn't the device driver plugin model very similar to this, except that it talks to Kubelet directly instead of through the runtime? Is there a reason why that wouldn't solve providing the QoS resource through a device driver plugin?
You mean the device plugins?
Yeah.
Interface?
Yes.
I guess one main difference is that with those you always have some amount of some like capacity. So you have like, let's say vendor.io/accelerator device X, and then there is some numerical capacity like 10 available on this node. And here we are basically having class IDs. So like tags in a sense. So different kind of mechanism in that sense. So you don't necessarily allocate any number of let's say, or there might be no capacity for this certain class if it's, let's say, some throttling parameters. So you can apply those throttling parameters as many any containers or pods as you like.
So just to clarify, if a pod says it wants to use QoS res C, there is no limit to the number of pods that can use QoS res C. I mean, every pod on the node can use it. There's no capacity concept in this.
There is like optional capacity concept there as well. So if you want to limit if you determine some like high priority class, there is possibility to limit the number of users, but not necessarily.
Okay, because I mean, if there are multiple classes, why would anyone use a lower class if everyone can get the best? There must be some resource limitation somewhere, right? Like, why would anyone use, say, silver or bronze if everyone can get gold all the time, even if they don't need it? There must be some resource limitation somewhere.
Possibly, or if you know your workloads, you know that you want to give, for example, your like high priority like container in a pod, like better priority. So you probably want to give that, let's say, class gold, and then for some like logging or some other not that important sidecar, put it into low priority so that it wouldn't interfere with your important workload.
Marcus, the question is more about the quota mechanism.
Okay. So then in this proposal in the further implementations in the future, we have kind of plans to extend the resource quota mechanism in Kubernetes and limit ranges as well, so you could, like, from the admin level, restrict the usage of some classes for like per namespace. So limit, like completely ban some classes, or then limit the usage of classes. So you can limit. There are mechanisms to limit that, like per namespace as well. So then a few words about the kind of network QoS proof of concept that I'll like demo next. So in this demo, we have like a simple usage scenario, or simple example of using the bandwidth plugin to implement some kind of network QoS. So we've extended the CNI spec or parsing of the CNI spec in Containerd to have a new kind of top level field called QoS, under which you can specify classes, in this example on the right, like fast and slow, and then there you can specify the capacity, and then we use the capabilities mechanism in this proof of concept to actually kind of enforce the parameters, or deliver the parameters to the CNI plugin. So this is how it looks like, and I guess that's it. I could switch to the demo part so you can see how that works in practice. So next, switch over to the console. So do you see the terminal?
Yes, we do.
Yeah, is the size kind of bearable? I mean, the text size readable on your screens? Should I make it bigger?
So looks okay to me. Others have any concerns? I guess we could go ahead with.
Yeah, okay, cool, yeah. So this is the one node cluster running pretty recent version of Kubernetes and Containerd with the proof of concept code running. And we have, or I have implemented this network QoS here. So let's see first the kind of how the CNI config looks like. So here, like simple, the basic plugins setup is really simple: bridge and then bandwidth plugin here. And then we have a few QoS classes defined for this. So slow, normal, and fast. And let's, for example, in this fast, you have like capacity of only one, and then we have capability as well, only bandwidth capability defined for this, or any of these classes. And then if I take a look at the node, we can see that there are like pod level QoS resources, only one, so net resource, and it has like fast, normal, and slow classes available. And then there are like capacities, so fast, one, normal, kind of 8 users, and slow network, you can have infinite number of users. And then there are some pod level, container level QoS resources as well, like block IO for the local disk IO, and then RDTs for the cache and memory bandwidth controls. And then like a simple pod would look like this. So you would have on the pod spec this QoS resources, or could have on this pod level kind of QoS resource requests like name, net, and then the class fast. And then per container you can also have, but we are not interested those in this demo probably that much, but similar thing for container level resources. And then if I run that workload, now it's running, and then if I take a look at the node, then you can also see it from the node status that okay, now the kind of fast network has been kind of saturated from the capacity point of view. And then if I try to run second pod also requesting this fast network, then let's see. Okay, so now the second one is pending, and then it says that okay, insufficient class fast of pod QoS resource net. And then if I delete the first one, then the second one is running, and kind of, yeah, that's how it works and looks like from the user's perspective, like simply about you. And then this kind of QoS resources are also kind of dynamic in the sense that if I, for the Containerd runtime reads or has a FS notify on the CNI config. So if I create a, let's take this one. If I create a new class here, let's call it foobar and put some capacity here, 5, and then some parameters. parameters, then we should soon see that, okay, so now we have see that, okay, the foobar class was actually added to the node and then its capacity. So that's how the network QoS looks like in a simple way. So any
Yeah,
comments, thoughts? Yeah.
a couple of questions. So the reason why this network QoS is in the CNI config, I mean, every time you need to add a new, class, you need to go into the CNI config or have some tool change it in all the nodes that's outside of the SCEP.
Yes.
Okay.
Yes.
And
yeah, actually, sorry to interrupt. So basically, this KEP is really about the KEP itself is really about the Kubernetes API and the CRI API between kubelet and the runtime. So all the CNI bits and kind of the implementation details of how specific QoS resource or mechanism, like let's say network QoS or this CAT bandwidth allocation or whatever block IO or some other QoS mechanism, the implementations of those are kind of strictly out of the scope of this KEP. But we have like just demonstrating few of these kind of possible usage scenarios for the KEP and network.
Okay.
Yeah.
And so when I mean, I don't know enough about the CRI, but to me, the CRI doesn't do much when it comes to networking and network stack.
Yeah.
And in this case, its job is to only why is the CRI? Why does it even need to know about network cost classes? What is it actually doing?
So the CRI is only, first of all, from the runtime kubelet to then the API server, like the kind of resource discovery. So the runtime is able to tell basically to Kubernetes that, okay, what network classes are available on this node. So nothing else, kind of just advertising. And the other way around, then when a pod is created, then the CRI is only needed to, when the pod sandbox is created, to able to say that, okay, this pod belongs to this network class, and that's basically it. So nothing more. And then when runtime gets that, okay, network class, let's say fast, then in this proof of concept, at the kind of pod sandbox creation and then the network setup phase, it then actually does whatever the QoS class means.
Okay.
So the CRI is really just this let's say the simple messenger there in between, or mailman.
I see. And so circling back to my earlier question, is if the device plugin interface only accepts numeric values, which is the major concern of you going down that path, it would be interesting to see if we should evolve that interface to support this use case. Is that all required to support this use case, or is there more than that?
It's more than that. So the main goal of QoS classes or QoS resources is not to teach kubelet what it actually means. So like to let all the implementation details out of a kubelet. So the device plugins interface is hard coded to like certain level of assumptions. like where countable extended resources is one thing. So like you cannot have infinity amount of resources. And when like all the advertised resources is equal, meaning what like the kubelet will make a decision which one to allocate. And when like it has like bunch of parameters which is related only to devices like accelerators and so on. So extending that interface is pain, and practically like the whole reason why things like, for example, like dynamic resource allocation was implemented, or what this QoS classes was implemented, is because like this device manager and device plugins are beyond of being refactored.
Okay,
Yeah.
so the interface for device plugins is beyond repair. Therefore, we are going with a separate path for QoS. Is that the high level summary?
Yes, so like the main design differences between what was done for device plugins and compared to what DRA is doing or what QoS class is doing is what kubelet doesn't know anything about what it is, and runtime to some extent also doesn't know what it is.
Mhm.
What we can do and what is part of a protocol between the components is what like it knows what is discovered, and it knows like when the pod or container requests something, so it passes those identifiers, and when the low level implementation actually expands those identifiers to some of the parameters. Like example, what Marcus was showing in his CNI config. So CNI config defines what, like I know the QoS foobar and I know the capacity. And that's the only information what like runtime passes to kubelet and kubelet passes to scheduler. And vice versa, like when the pod is requesting, it says, I want to use QoS class foobar. And kubelet just passes that string foobar down to runtime. And in CNI invocation pass, this foobar is actually expanded to like injected with capabilities fields. So like the main difference is what, like, let's not complicate more kubelet beyond what is already complex.
Mhm.
So it's just like those protocols is just the messengers to deliver the key information, and how what is behind it, it's implementation details on the
Yeah.
level.
And then,
Yeah.
and then one more like aspect of this QoS and the kind of tight coupling to the runtime is that many of these QoS mechanisms are kind of really tightly tied to the kind of OCI level, let's say, container life cycle, and kind of you need to do the right things in the at the very kind of right moment in the kind of pod or containers life cycle, and then having this device plugin mechanism like outside runtime plugins is not really feasible, at least with the current design, and kind of probably beyond repair on that
Okay.
front.
So the device plugin, which is also used for SRIOV and a bunch of other use cases, right? It is also the one that is doing the actual enforcement or implementation, because kubelet is a pass-through even for the device plugin, as far as I understand. I guess what you're saying is that kubelet is a pass-through for device plugin, and it seems like kubelet is a pass-through for CRI in this particular case as well. The only difference I could sort of glean from the demo is that, at least for the networking use case, whatever information you pass through CRI gets passed on to the CNI, so that the CNI doesn't need to go and look up the information from some other resource, right? It's getting it through the CNI call, right?
Mm-hmm. Yeah.
In other case, it would need to go, do a lookup to get more information, like Maltese, what Maltese does or whatnot, right? need to go look up something in the API server to get more information, which I guess could be, it could be beneficial.
Yeah.
But then
Yeah.
every time you want to add some parameter or some, you want to modify. I mean, the good thing about the earlier approach would be that if you want to change the spec to add a new field, the CNI would need to change versus the CRI, and I don't know if kubelet would need to change. Is it opaque for kubelet or not in this particular case? So that is, I guess, how would we handle that? I mean, you want to add a spec, what kind of changes would be needed? You want to add something to the spec. What kind of changes would be needed here? When I say add something to the spec, I mean, let's say that, you have this QoS, slow capabilities, bandwidth, etc. Right? Let's say there's one more field like bandwidth, right? I don't know, rate limit or something. You can just think of something, right? Is that so? You would just need to change the CNI config because the CRI would map the QoS source name to the name of slow, foobar, normal, and take whatever capabilities are there and then pass it on to the CNI call. Is that how it would work?
Yeah, exactly. So yeah, from the CRI kubelet to runtime, you only get this network and then class name slow, and then in this kind of proof of concept, then the runtime knows that this pod belongs to class slow, and then it goes into the takes a look at the CNI config. Slow means then capabilities, and then pass whatever capabilities it has and passes that to all the plugins that are interested in this capability. So
Okay.
yes.
Okay.
And then and then kind of and in the perspective of multi-networking, definitely this I don't believe then this QoS resource mechanism would be kind of managing devices or anything like that, as said. So that would be DRA, but possibly just to kind of get and kind of give you the understanding what this KEP is about. So possibly this could be used in some like Malthus scenarios to like pick the kind of default network or something like that. So you would have just capability, whatever, and then through this capabilities mechanism, pass down some parameters to Malthus. Or we could add like environment variables here as well. But anyway, kind of pass down some parameters to the CNI plugin or plugins. So that's the kind of what this QoS KEP could be, or could be used.
So if the CNI plugin doesn't need to go look at something in the API server, and it would get everything through the CNI call, add or delete or whatever it is. I guess this could be useful, but also I'm not sure if changing the CNI config dynamically every time you change, you add a new class, remove a class, or change fields, you have to change the config, and you need a tool for that. I'm not sure if that is a typical pattern in Kubernetes. I don't know if others have any comments about that. I mean, I thought that's what CRs were for, but maybe,
Well, it's not something what you want to change too often. It's practically like it's your configuration, what is available on your node. Like for example, like statically provisioned VLANs or statically provisioned interfaces. Second thing, like some of the CNI plugins, like Viv Network, like when the daemon set is deployed, we provision their own CNI configs. So it's dynamic by the nature, and runtimes are handling what, like if anything in the CNI configuration directory changes, it rereads the configuration. So the next pods which will be started, it will be using the new configuration files. So,
no, I understand that part, but adding a new VLAN or which translates to perhaps adding a new network is a dynamic enough change that we would expect that, for example, there are trunk ports where you don't really need to add a new VLAN on the interface to say that this VLAN is available on this node, right? But you would want to model it somehow so that a pod could say, when I send traffic, please make sure it goes out with this VLAN tag.
Yeah, but again, here's what two big differences. Like the QoS classes, it's considered to be like for let's say like scenarios when you need to select the default network, like one or another. And those are usually like pre-provisioned at what node startup time. We are picking back on what runtime can read the configuration, so we can update those resources, but we are not requiring that. So the scenario when this particular VLAN needs to be provisioned, it's better fit into DRA usage pattern.
Yeah, so we should talk more about the DRA, and I don't know if folks on the forum have read up on it or seen a demo of it, but it's possibly of more interest in the multi-networking space, the DRA part. I have a bunch of questions in that area.
Yeah.
So is that, I'm not sure, do we have, is that something we should schedule for the next session? Would that be of interest to everyone?
Yeah, I think that would be interesting.
Yeah.
Okay.
I agree. And I definitely, as I said, I definitely agree that the DRA would be the, well, in my opinion, if any of these kind of the solution that would kind of be able to solve the user stories that you have listed. But yeah, that's kind of just sharing information about the QoS ResourceScape and how that might be in some scenarios possible to kind of use that, but definitely it's not, this QoS ResourceScape is not kind of
okay. So
yeah, satisfying all the user stories. That's for sure. Yeah. So
we can add it to the agenda item next week, and Marty will be back, so we'll have more context about it, because I remember Marty and myself. I'm sorry, I forgot this person's name. Running into someone in KubeCon, US in Detroit last year, and they were presenting DRA back then.
That was probably me.
that was probably so. Yeah.
Nice to again. And I remember us discussing, because at that time multi-network was also in very early stages, and I remember us discussing synergies back then. I mean, I do have, at that point we went and read through the KEP. I'm not sure if the KEP has changed after that point, the DRA KEP that is. But we have at least I have a lot of questions specifically about, in my mind, for some reason, DRA keeps mapping to helping with scheduling. And if it's more than that, then maybe it's time to refresh at least my knowledge of it.
So
yeah,
if I may reply, because you previously was asking about the device plugins and so on. So the DRA helps to scenarios similar to the device plugins.
right.
It also in the current implementation talks about like the, let's say, like PCI devices or character devices. So like if your VF provision it into pod as a PCI pass-through device, let's say for DPDK usage, DRA even in current shape, it can help. And the main thing what it can help is to pass the parameter. So you can say, I want VF, which is, let's say, connected to particular trunk port. Or let's say, I want to provision like something to a particular VLAN, like my third, fourth, fifth interface and so on. So like it allows you to do the parameters. It allows you to do like dynamic reconfiguration of accelerator devices, and it allows you to put like pass-through devices.
Right.
But it cannot handle the network devices in terms of like Linux network interface things. And this is where we want to have like this plumbing done for QoS resources and for DRA to also handle those kind of interfaces, like LinuxNet.
So I think that's the part I also have some questions on. The resource management, it seems like what is the underlying resource that is going to back, the network path for a new network that a pod wants to use, which is either VF or SRIOA or whatever it is. That's one part. But the representation of the network itself, in other words, is that a VXLAN network, right? I want to connect a pod to a VXLAN network, not a physical network. So what is a VXLAN network that I want to connect? What is the tunnel parameters? What is the other end of the tunnel, etc.? Those kind of definitions. Also, once you assign a pod, once a pod says I want to connect to the network red, blue, and green, where red is a VLAN, blue is VXLAN, and green is something else. How do we do IPAM for some of these? Right? Where do we define how IPAM is going to get done? Is it coming from the network? Is it coming from somewhere else, etc.? And the other part is after the pod has come up, how do we represent these networks in other Kubernetes concepts like services? When you create a service, would you want to say that I want a service for the blue network, pick these set of pods that are participating in the blue network and create a service for them, right? And those pods could be in blue, red, and green, but you only pick the interface from the blue network and use that as a backend. So representing that interface inside a pod after the pod has come up so that it can be used in other second level constructs like services, network policy, etc. And doing IPAM while bringing up the pod and identifying how do I plumb the networking stack on Linux so that it can go to the right tunnel or the right VLAN, etc. Those are some of the things that I think that multi-networking is toying with. And that's where we need to identify where the intersections are.
So, just to reply to some of your questions. So regarding IPAM and like all the parameters, let's say like for VXLAN provision, it can fit into the semantics what DRAs do. So you can have like your custom parameters which say I want VXLAN, I want this with those parameters. And all of this will be in your vendor specific logic. So it's not part of a core Kubernetes. You don't need to change anything in that. So that is a part. Regarding IPAM, like my understanding right now, it's done again, like part of a CNI config. We can discuss what will be the best method of doing that. So if we are like still piggyback on the CNI specification, when we can run, for example, like the pod with different CNI config, or with like doing like few invocations with different CNI configs. It's also possible, but again, like it's implementation details what we can figure out, because we are not masters of the network. We understand something, but well, those details we need to discuss in more detail separately. Regarding services, again, we have some ideas how we can reference that. So instead of like pod selector, we can point to the claims. Let's say like the claim which says like blue network, we can point it to those claims in the pods, and when it can get from status fields like IP addresses for it. It's again, we don't know if it's usable in current idea shape or not, but it's again like it's a secondary detail thing which which can be like separately discussed.
Okay, so otherwise, I mean, those are the I don't know if these have been called out in the CUJ list, because we're probably at the initial stage of how to bring up the pod with the right interfaces, etc. Right? But the goal was to make sure that we can provide these second level constructs a way to identify which network are they talking about, right? We're probably out of time this session anyways. We can add this to the agenda item for next week, and Machi can come and help coordinate that part. All right, so does anyone else have any other comments, questions? Okay. Well, thank you.
Marcus, if you can bring one for a few seconds with slide with different user stories.
Yeah. Yeah. So I guess like from my point of view, it's kind of we are really not that well educated on the network side, but kind of our idea is that okay, we have some kind of ideas and proposals, and we are kind of trying to figure out figure out if we can help you with some of your use cases. So kind of knowledge sharing and
So I just wanted to again like comment about this particular thing. So like there are several like moving pieces in all of this. Like there is DRA, there is QoS resources, there is also another thing which is called NRI, Node Resource Interface, like a plugin mechanism on the container runtime sides. So some of them can help with different scenarios and like integration to this like third-party entities like services and so on. It's also like one and big open questions. But I think what Marcus is doing with QoS resources, it's a more convenient way to pass the parameters to plugins like Multus or like bandwidth instead of annotations. So think about it like as a replacement for annotations.
No, that's I think that came out quite clearly. Thank you for that. And I guess we'll just have to see if you have to go to the API server to look up some CR anyways, does it help? I mean, does it matter if the information comes through the CNI? You can also get the same information through the CR lookup. That's what I was trying to allude to.
That's the thing we're trying to avoid. We want to pass enough information like up to a stack, like to kubelet, to scheduler, to make the decision like should this pod running on this node or not, and at the same time like not to teach the Kubernetes about like complex things like what those things means. So like pass enough information to apply whatever resource constraints is needed to the workload without like forcing you to look up information somewhere else.
That's true. What I'm trying to say is that for the multi-network case, we should see if we can get away without going to the API server. I mean, the way it is going right now, it doesn't seem like it, but maybe we should evaluate that, right?
Well, again, like that's the reason of this table. So, like the DRA can pass a lot of information down to to consumer on the node, and that was specifically designed for device plugins where we can like fit all the needed parameters like mount, environment variables, device nodes, like hooks or whatever, like annotation, additional ones if needed. So like when we're injecting device into a container, like we don't need to go and fetch information anywhere. So for network scenario of DRA usage, we want to have exactly the same thing, like figure out what information needs to be passed, so you can get the same experience.
I see. Okay.
And QoS is just like more simple way for things like what can be expressed instead of annotations, like including like quotas and default mechanisms. So again, like putting more order instead of like wild west of annotations.
That's true. But I think what I want to call out is that networking, as you can imagine, is not a one size fits all, right? Every pod can have a completely different default network. Every pod could say, pod A could say red is my default and pod B could say blue is my default. So it's a very pod specific configuration. And if we have a way to pass that around without going to the pod spec, that's great, right?
Well, that's why the QoS will help. So you can say like QoS net red, and this will be your default network.
And it also kind of that helps with the scheduling part. So you can have like heterogeneous cluster where some networks or classes are not available on every node. So with annotations, it's like wild west. But with this, the scheduler knows what is available where and kind of
but these configurations that I'm talking about has nothing to do with scheduling, right? I mean, scheduling is basically saying the pod can I put the pod on the node? after that decision has been made, the stuff that I'm talking about is how do I set up the pod's network plumbing, right? So for the scheduling part, I understand. I mean, either we use the device plugin method or DRA method or one of those, right? To identify, can this pod fit in on this node? Does all the requirements of the pod need? It means it needs red, blue, and yellow. Are those networks available on this node, right? That I can see that, right? The part is like, okay, they are available. Now, how do I plumb this information? And which of these networks is the default for this particular pod, right? Now, so it's beyond scheduling. That's why I mentioned the last team meeting as well, that there's stuff that's happening beyond scheduling. Scheduling is just the first step for the network plumbing piece. Okay. Anyways,
but in case of QoS, the scheduling also inside like decision chains, because again, like you can express the default network using QoS classes like red, blue, whatever else, but not all of those network might be provisioned on all of your cluster nodes. So it will help to select, like if a pod says I want blue as default network, it will be scheduled only on the node where it can be done.
And device plugins can do that today. I mean,
device plugin doesn't handle the Linux network interfaces. It's only
but it does tell Kubelet, and Kubelet does tell the scheduler what is available on each node. And that's enough to get the scheduler to decide whether to put the pod on the node or not. The question is the network available there or not? That is the first question. Once that is answered and you land a pod on the node, then the plumbing for that pod on the node is handled locally on that node through CNI and whatnot.
Yes,
right?
but
I mean, that is one model, right? So anyways, sorry, I didn't mean to interrupt. We should probably wrap up the session. It's way over time.
yeah.
So I'll put up an agenda item for DRA presentation, and if you could, give a demo and presentation just like this one, that would be really useful for the next session. This is really great. I think I hope everyone, others also, benefited from the QoS demo. I think I have a better understanding of what the QoS was trying to do. Thank you.
Thanks. We'll continue.
Yeah. Thank you guys for your time.
Bye.
See you next week.
See you.